Alright guys, what's going on? So we're picking up on the Finance from Physics playlist. This is, we're drawing analogies basically between financial economic systems and physical systems, i.e. physics, and we're sort of bridging the two together to get a more cohesive understanding of both areas of study. Okay, so last time we sort of went over this picture of local transformations and global transformations. Right, so global transformations, those gave us relative prices within countries. Okay, local transformations were a little bit different because of these exchange rates, right? So when you have exchange rates between two countries, then that exchange rate is going to help facilitate local transformations in keeping arbitrage an invariant quantity under those local transformations. Okay, so relative prices, again, those are the sort of invariant properties that global transformations are attributed to. And then arbitrage is the thing that is an invariant property that local transformations are associated with. And so from the arbitrage, we were able to get this thing, this gain factor, right? So this gain factor was this notion of what happens when you perform exchange rates between neighboring countries, four neighboring countries coming back to the same point. So, and at that same point, the question that this thing tries to answer is how much do you gain or lose upon that exchange? Okay. And then from the exchange rates, we got these commodity fluxes, and the equation for that was this guy right here. But we needed to know the prices there. The prices, so the arbitrage, or this here was the exchange rate, right? So this A mu, and then this here was our prices between two countries, right? So the derivative of that between the two. And gave us an idea of what the flux is like between two commodities, or between the flux of a commodity is like between two countries. Okay. So arbitrage can be dynamic though, right? So this thing, we're saying it's an invariant property of local transformations, but it can be dynamic in time. So the dynamic nature of the arbitrage is still there. It's just that dynamic nature doesn't depend on the local transformations. In other words, the local transformations doesn't drive the dynamics of the arbitrage, but nevertheless, the arbitrage can be dynamic. It's just invariant under local transformations. Okay, so we need to find a way to model how it changes in time. So let's now take a look at a more holistic picture of, perhaps I've been modeling Europe, and we'll just keep on focusing on Europe. We could do this with the whole world. We could do this with different countries, different neighboring countries, and so forth. But I'm sticking with Europe partly because it's kind of easy to make an image of Europe. In order to do this, let's consider the flux of goods from Switzerland, right? So here's Switzerland, and we're putting a ball around Switzerland, and we want to calculate what the flux is of goods coming out of, or sort of leaving Switzerland, if you will, and coming into Switzerland. We want to be able to calculate this. And so the question is there a way to relate the flux of these arrows to the gain factor for Switzerland? And so we're going to try to do that in this video. I forgot to mention, make sure to hit the like and subscribe button if you enjoy this kind of content. Let's just keep on going. To answer this question, we will discover a formula that we'll be able to use to link our mind map in the following way here. So again, we have our global transformations. What we want to be able to do is we're going to find a link between the arbitrage and the commodity flux. Okay, and that's going to give us an idea of how the arbitrage changes in time. Okay, so let's think about this intuitively first. Does it make sense that arbitrage would drive the flow of goods in and out of a country? Yes, it does. Recall that arbitrage is like a gain factor, and so it represents how much we stand to gain if we buy and sell goods in different countries or in different markets. Okay, so suppose we have, Great Britain, we have Germany, we have Italy. And perhaps the exchange rate is 10 to 1 between Great Britain and Germany, and 10 to 1 between Germany and Italy. So if Germany buys 10 oranges, again, my apologies for the dogs. If Germany buys 10 oranges, then they spend 10 Deutschmarks. Okay? So if they're buying from UK here, their exchange rate is going to be, if they buy 10 oranges, right? So they're going to spend 10 Deutschmarks. Okay? If they sell 10 oranges, they're going to gain 100, right? Because they're selling in this direction and they're buying in this direction. And so Germany, and let's see if we look at this, Germany sells 10 oranges, they gain 100 Deutschmarks. So they're selling here, if it's 10 oranges, it's going to be 10 times 10. That's where that 100 comes from. Okay, so Germany I should be a little bit more clear here. They're buying 10 oranges from, Great Britain, and here selling to Germany sells to Italy, right? So the net result of buying from England and selling to Italy 10 oranges is 90 Deutschmarks. So that's a gain. That's a gain factor, right? So let's take a look now at this picture. So here's our gain factor equation that we've established. Our exchange rates, AJ and AI, and then the derivatives of each. So we've established this equation already. This is our gain factor. In physics, this takes on a different name, and we'll come across this later. But let's take a look at this picture now. So when we're talking here, in the case of this AJ, we're going in the J direction. Okay, so suppose we have an axis. All right, and here's our x-axis, right? So our x-axis we usually associate with I, and our y-axis we usually associate with J. And so we have our I unit vector and our J unit vector. And so what we can do, what I've done here is I've said, okay, here's Germany, and it is, the ratio again is 1 to 10 for Great Britain. So 1 to 10 for Great Britain. Okay. And the change in this as we travel in the I direction, right? So in the I direction is we can see a shrinking of this area. And that's how I want to depict this. Okay. So we see a shrinking in this area of the exchange factor as we go in that direction. Right. Notice we've put another country here. And so this country is France. Actually, you know what? The shapes of my countries are not great here, but I am calling that Germany. This is, what country is that? The shape. Not France. What the heck country is that? Not Spain. Realized I forgot to put Portugal in here too. Let's see, so... I see. This is supposed to be France. Right, so France, this is supposed to be France. So let's name these countries here. France, Germany, Great Britain, Italy. Okay. So, okay, just we go back for a second. This guy here is, this is supposed to be France. Okay, we're just changing the names of countries. No math is being compromised here. But we could see here, okay, so the exchange rate between France and Great Britain, we said, was 1 to 10. And what we want to do is we want to take that exchange rate and we want to take the derivative as we move in the I direction. And then we're going to do the same thing for this guy as we're moving in the J direction, right? Because we're moving in the J direction, right? This is the J direction. All right, and we can see that the length of this changes, okay? And the length of that is changing, the length of it changes is changing to illustrate that there is a change here. Perhaps there's no change, right? Perhaps there's no change. If there was no change, then they would be the same length. Okay, but here I'm illustrating a change, and we're going to see what comes of this, okay? All right, so now we're introducing something like a competing exchange factors. If Italy stands to gain more from buying from France, right? So this should be France because I changed France. Then with Germany, this should be Germany, the red box. Then the flow of goods from Germany to Italy will be affected. So from Germany to Italy will be affected. Again, so think about this really quick. If Italy stands to gain more from buying from France, if it stands to gain more from buying from France than with Germany, then the flow of goods from Germany to Italy will be affected. So from here to here is going to be affected, because if Italy says, we stand to gain more from buying from them, then we're not going to deal as much with Germany. Okay. Whereas if England sells to France, right? This is where I should get the shapes of my countries, right? This should be France. Then with Germany again, right? So here, if England gains to sell to France, right? So sell to France. Then with Germany, the orange box, then the flow of, I've realized my faces, so France and Germany. Then the flow of goods from England to Germany is also going to be affected. So a tension arises when we introduce Germany into the picture here, which directs the flow of goods or the flux of goods in and out of France. Okay? So this is the picture we have now. So there's a tension. So when we introduce Germany to the picture, we introduce a tension between Italy and Germany, because Italy's saying, okay, if we're buying from, we can either buy oranges from France or from Germany. They have to ask themselves the question, who do we stand to gain from in this perspective? Or when we're buying, gain sort of it doesn't mean when it comes to money, it means do we have to spend less if we're buying from France, whereas do we have to spend less if we're buying from Germany? Okay, that's the question we're asked. That's fundamentally the question that Italy has to ask. Okay, and then we do the same thing here. England, they're selling, and when they're selling, they need to ask the question, okay, if we're selling to Germany, or France and Germany, which one are we going to get the most out of? Okay, and so a tension arises between these three countries, the countries that I highlighted up here. Okay, that tension I'm illustrating with these blue bars. Okay, and so another way of thinking about this is that if Italy stands to lose less by buying from Germany than with France, there's a change in the arbitrage for France, because it must be forced to pick a different country to trade with. This change is related to the flow of goods out of France, and so we can write that the derivative of the gain factor, that's the change in the gain factor, is going to be proportional to the flux of goods out of some country, okay? To make them equal, we're going to add a proportionality factor. And this is the relationship, right? It's really not that difficult to come to this now that we've sort of talked about intuitively what this means. What really happens, what's really going on here is that you have three players here. One player, so you have three players, the UK, you have France, and Italy. But then when you introduce a fourth one, then tensions begin to arise, okay? And we can see here that we're doing this in the J direction, where so the gain factor in the J direction. So again, that's in this direction, okay? Of Fij is going to give us the flux in the I direction, right? So that's in this direction, okay? So, and this is the one way we can think about this is this index matches this index, okay? And what we're left with is the I index, okay? But really, again, the point here is that the change in the gain factor, change in the gain factor is going to tell us something about the flux of goods from some country. So when we're talking about France again, we're talking about France here. The flux of goods is going to be. We can actually draw this, right? So if we have our I direction and our J direction, and remember Fij now, and we're taking the derivative, the jth derivative. So the derivative of the gain factor in this direction, that's going to give us the flux here, okay? So that's one way of thinking about this. So I don't want to get too much into the weeds on of this way of thinking about things. Just we now can come to the understanding, though, that a change in the arbitrage for France, because buying from, so if Italy stands to lose less by buying from Germany than with France, then there's a change in the arbitrage. And that is going to drive, or that's being driven by the flux of goods. Okay. So this is this is the relationship between the flux of goods and the arbitrage. So from this we can derive the inhomogeneous and homogeneous Maxwell equations as well in physics, which we're going to talk about. But we need to talk about trader dynamics first. So before we end this discussion, let's think about this physically. The derivative of the arbitrage is like a flux, and the flux arises from tension between competing exchange rates. So now let's return to our mind map. So here's our mind map that we've been developing. So now we have our link. We have the link between the arbitrage and the flux, okay? We briefly mentioned how all of this is related to phenomena in modern physics. So we're going to go through this in more depth later in videos, but let's briefly mention the topic of U1, SU2, and SU3 representation. So arbitrage is the gain factor associated with buying and selling commodities, as we've sort of talked about in recent videos. This gain factor can be represented in different ways, though. So it turns out that we will be limited to representations that are compatible with transformations in special relativity, called Lorentz transformations. We therefore have Lorentz transformations and gauge transformations that we're going to have to talk about. The natural question is, what are the things that act as exchange factors to make the things that they act on locally invariant? To understand this, we need to talk about trader dynamics. And so we now want to introduce this picture where we have Poincare transformations. Poincare transformations are more of a general class of Lorentz transformations. And these things are transformations on space-time coordinates. And then we have gauge transformations. These things are going to be transformations on a gauge field, right? And when we're talking about gauge fields, in this case, we're talking, or in the Poincare transformation case, this is general relativity. General relativity. T, and in the gauge transformation case, well, this is going to be general relativity, and we also want to talk about them in quantum field theory. And for gauge transformations, we're going to talk about E and M. Right, so E and M. All right. And so that is what we have for this video. So now we've sort of talked about how we can make sense of the link between our arbitrage and our commodity flux. And in the next video, we're going to dive deeper into this. So, well, specifically not arbitrage dynamics, but we're going to get closer to talking about trader dynamics and how this is going to help us understand things as well. So, with that being said, make sure to hit the like and subscribe button, and I'll see you guys in the next video.